All right, let's talk about a challenge that honestly we all face. How do we take the random, messy chaos of everyday life and actually turn it into something structured, something we can understand? Let's dive right in.
So take a look at this. It's just a pile of old shopping receipts, right? Maybe trash. But what if I told you that buried inside this mess are actual secrets, hidden patterns about how people behave? The real question is, how do we get them out? Well, before we can find any of those cool patterns, we have to face a big universal truth. Real-world information is never perfect. It's messy, it's incomplete, and a lot of the time, it's just plain wrong.
And here's exactly what I'm talking about when I say dirty data. You see this? The quantity for milk is just missing. Then there's a t-shirt that apparently costs over 700 bucks. Yeah, I don't think so. And down here with the chart paper, the math itself is just wrong. This is the kind of chaos we have to clean up before we can do anything else. So, where do we even begin with all this? We need a system, right? The first step is to come up with a simple, repeatable process that lets us look at every single piece of information one by one. Let's just imagine we want to find the single most expensive item in this whole pile. The process is really straightforward. We create a little mental placeholder, let's call it highest price, and we start it at 0. Then we pick up the first item. Is its price higher? Yep. So it becomes the new highest. We pick up the next item. Is that one higher? If yes, it takes the top spot. We just do this again and again for every single item until there are none left. You know, this step-by-step repetitive process, it actually has a name. It's called iteration. And this is basically the engine that's going to power our whole analysis. It's how we can systematically work our way through a mountain of information without missing a single piece. Okay, so iteration works. It's great. But now things are going to get a little more interesting. What if we don't care about all the data? What if we only want to look at a specific slice of it, like just the spending on clothing? The solution is actually pretty clever. We just apply a filter. We add one simple question into our process. Hey, is this item in the apparel category? If the answer is no, we just ignore it and move on to the next one. This lets us focus our analysis only on the information that actually matters to us. So, as we're iterating and filtering, we're gathering a lot of really useful information. But, that creates a brand new problem. Where do we put it all? I mean, we can't just keep all these totals and customer names floating around in our memory, right? We need a structured way to store our findings as we collect them. And there are two really common ways to do this, and they both have great analogies. A list is kind of like using bookmarks in a book. It's an ordered collection, and it always remembers the position of each item. A dictionary, on the other hand, is more like an address book. You use a unique key, like a person's name, to instantly look up their information, like their total spending. Okay, so we're cleaning, iterating, filtering, and storing data. But you might notice we're doing similar things over and over again, like calculating the totals for each and every customer. There has to be a more efficient way. This quote just hits the nail on the head. Instead of doing the same repetitive work ourselves, what if we could delegate it? What if we could create a little subcontractor to handle a specific job whenever we need it? Well, that subcontractor is what we call a procedure. It's a named, reusable recipe of instructions. We design the recipe just once, let's say, calculate totals by category, and then we can call on it whenever we need that job done. And here's the magic of it. We can use the exact same procedure on different sets of data. We give it bill 1, 2, 3, and it gives us the totals. Then we give it bill 4, 5, 6, and it does the same job but returns a completely different set of results. This is how we build complex systems efficiently, without reinventing the wheel. Okay, this is the moment we've been working towards. We've cleaned the data, we've built our tools, and we've organized all the information. Now it's time to see what all that hard work actually reveals. Just look at this. That messy pile of receipts has been transformed into this clean, beautiful table. For each customer, we now see exactly how many items they bought in each category. All the chaos is gone, and it's been replaced by pure clarity. And with our data structured like this, we can finally start looking for those patterns. The method we use is called binning. We basically just create bins or groups for customers who seem to have similar buying habits. And just like that, distinct patterns start to pop out from the data. We've found 3 types of customers. You've got the focused shopper, who only buys stuff from one category, like groceries. There's the food plus shopper, who mostly buys food but grabs 1 or 2 other things. And then there's the high volume shopper, who buys a little bit of everything. So, from a pile of what look like random receipts, our systematic process has revealed three distinct, identifiable patterns of human behavior. How cool is that? This whole journey we've just been on, from messy data to clear insight, from total chaos to a clear pattern, this entire way of thinking has a name. It's called computational thinking.
And this right here, this is the toolkit you've just been using. You practiced decomposition by breaking the big problem down into smaller parts. You used pattern recognition to find those customer groups. You used abstraction when you created that reusable subcontractor procedure. And the whole time, you were designing algorithms, the step-by-step instructions to make it all happen. And this isn't just about receipts. This way of thinking, this systematic creativity, is the absolute foundation for how we build search engines, how we analyze scientific data, and how we solve some of the world's most complex problems.
So I'll leave you with this question. Now that you have the toolkit, what messy problem in your world could you start to solve? What hidden patterns are just sitting there waiting for you to discover them?